In this video, we are going to learn about the effective annual rate of interest. Right. So we have one example which is dealing with this effective annual rates of interest. Okay. A bank offers two accounts. The first account is offering 4.6% compounded monthly, and the second offers same 4.6% but compounded quarterly. So that is the difference. The rate of interest is same. Okay. So in this scenario, what are the effective annual rates of interest for each offer? We have to find the effective annual rate of interest. That's the first part. After doing this first part, in the second, he is asking if you deposit $10,000 in each of those accounts, what is the difference in the balance? Will there be any difference, if at all, and by how much they differ? By depositing your 10,000 for where you compound monthly, the interest is compounded monthly, and if it is compounded quarterly, what is the balance at the end of 1 year? So that is the scenario here. So we are looking for the effective annual rate of interest. The formula for finding this effective annual rate of interest is this capital R. That is telling me about the effective annual rate of interest. That's the rate of interest here is equal to 1 plus I. This I is the rate of interest, that is 4.6%. That is I here, lowercase I, and N is telling that how many times it is compounded in a year. So here it is compounded monthly, so that N is equal to 12 in the first scenario, and here compounded quarterly in the second case. So I'll write N is equal to 4 because there are 4 quarters in 1 year. That's all. I is the same 4.6% and N changes for those two different things like monthly and quarterly. Alright, so that's what I have here. Okay, I is equal to 4.6% because it is given in percentage form. Change it to decimal. So on dividing this 4.6 by 100, 4.6 over 100 gives you 0.046, because monthly it is 12. I have a formula here. Quarterly, that rate of interest is the same, so it is 0.046, and N is equal to 4 because of that quarterly thing. Now let's substitute these values in the formula in the first and second case. Right, so 1 plus, that is I you got here, 0.046 over 12 whole to the power of 12 minus 1, and the same thing here, N is equal to 4, everything is the same. So let us work it out using calculator. Okay, I have here, let me start off with the parentheses. Okay, now 1 plus, it's 1 plus, have a fraction, so let me go to fraction, 0.046. You don't have to type in 0, it's just the same. 0.046 over 12, then come out of the parenthesis, come out of the fraction, close the parenthesis, and go to the exponent. I have exponent here, it is 12. Come out of the exponent, then minus 1. Let us see what is the result. Yes, 0.0469823, etc. So I rounded it to the fourth decimal. So, and here it is in the decimal form. So from decimal form, to get the percentage, you just multiply by 100. So that's what you have in the next step. 4.6982%. Okay, the same thing you can get here in this next part just by removing this, replacing the 12 with the 4. Your answer is going to be 4.680%, right? So these are the two different resultant annual rates of interest. The effective rate of interest is that. Okay, so that's the first part. Now in the second part, you are looking for a deposit of $10,000. Now when you deposit this $10,000 in each of those, what is the resultant amount at the end of the year? How much is your balance going to be? So once again, we have a formula here for the future value. So future value is equal to present value times 1 plus I over n whole to the power of nt, right? So our values are present value 10,000, rate of interest I is 4.6%, change it into decimal form, that is 0.046 in both cases. N is equal to 12 because it is monthly, n is 12, it's in fact lowercase n, and the t is the time period, that is 1 year. Same thing here, quarterly, so n equal to 4 and t is 1. Substitute those values in the formula. Let us substitute and then just use your calculator and you'll get the right answer. Let us verify one of these two and then we'll compare our answers. Okay, we have 10,000 here, so 1 0 0 0, 10,000, start parentheses 1 plus, I have a fraction, so 0.046 over 12, come out, close parentheses, exponent, and it is 12 times 1. 12 times 1 is 12, and I'll just write 12, enter 12 and hit enter. So that's your answer. Let me, okay, yeah, $10,469.82. Doing the same thing in the second case, we'll get $10,468. Sometimes if your calculator is not showing up fractions, if you won't get it, still it won't make any difference. You can just type in 10,000 parentheses. It will not make any difference. Let us see. 1 plus 0.046 divide, here it's 4, I'll close parentheses, exponent 4 times 1, that is 4. You can come out or just hit enter. $10,467.99.00. So I mean 90.99601. So that changes to $10,468. 0.996, you can just make it as 1. So that's what it is, $10,468. That is the second balance. Now, what is the difference you are saying? The difference between monthly, when it is calculated monthly, and quarterly. Obviously here we are seeing that this value, the first future value is slightly larger than the second, that is monthly is better than quarterly. So by how much? You have to find the difference, and the difference between those two future values is equal to $1.82. So your $10,000, instead of depositing in monthly account, if you deposit in quarterly, you are losing this much. To gain that, you better deposit in monthly. Then I have one similar problem here, but just the numbers are changed. Instead of 4.6%, we gave it as 5.2, and one is monthly and the other is quarterly. We didn't change there, and a deposit of 12,000 instead of 10. So please try to work it out. You will get the result. Thank you. Thanks for watching.